Hello students, this is Professor Chalai, and this will be a hopefully short video going over some of the calculations that you need for this week's lab. This week we'll be looking at acid-base titrations, and so by the end of this video you should learn about what acid-base reactions are, what acid-base titration is, and how to perform those relevant calculations. Let's get into it. First, let's look at what we mean by acid-base reactions. So you may have already touched on this in class, some of you may not. So for those of you still wondering, an acid-base reaction is simply a reaction between an acid. So an acid, according to the Arrhenius definition, is any compound that produces H plus ions when dissolved in solution, like HCl, hydrochloric acid. And a base, according to the same Arrhenius definition, is any compound that produces OH minus ions when dissolved in solution, like NaOH. In an acid-base reaction, we're switching around the cations and the anions. So in HCl, we have H plus cations and Cl minus anions. And in NaOH, we have Na plus cations and OH minus anions. So we're performing a double displacement reaction where we use the cation from NaOH, let's say, and the anion from HCl, so that'll give us NaCl aqueous. And then we'll use the cation from HCl and the anion from OH minus, that gives us HOH. Really, that's just the compound we know as water, H2O, liquid. And really, for all intents and purposes, an acid-base reaction is one that produces some salt and water. So that's an acid-base reaction. Now, acid-base titration is simply a setup where we have oftentimes a burette. So an instrument's a tall, long instrument, we'll call it a burette. And a flask below, where we'll usually have the acid, and in the burette we'll have the base, and here we'll have some indicator. An indicator is simply a compound, a substance that has a different color in the acid compared to a base, such that when the indicator changes color, we know we're exactly trying to switch over from being acidic solution to being a basic solution, and so we know that the titration is exactly we know that the acid is completely being neutralized by the base, and so we know when to stop the reaction. It means we've added enough sodium hydroxide to exactly equalize the hydrochloric acid in this example. So that's the basis of a titration. We have a burette, we have acid in our little Erlenmeyer flask, we have an indicator to tell us when it's over. In this lab, we're going to be doing two types of calculation. In the first part, part 1, we'll be doing what we call standardizing an NaOH solution. Standardizing here simply means finding the concentration of. And so what we'll have is we'll have our burette set up with our NaOH, but this concentration will be unknown. And our job in this first part is to find the concentration of NaOH. In our little Erlenmeyer flask, the acid I'll be using for this is going to be HKC8H4O4. And we're going to use, in order to know exactly how much of the acid that we have, we're going to use an amount measured in grams, because this is going to be a solid acid that we dissolve in water. So let's say we measured and it has about 0.523 grams. And then, as I mentioned earlier, we're going to add indicator to know when the reaction's over, and we're also going to add water to just dissolve the solid acid that we use. So this is what we're going to set up. By using an exact amount of acid dissolved in water, we can exactly figure out how much moles of acid we have, and so when the indicator changes colors, we can use that to figure out how many NaOH we used. So let's say we used 0.523 grams of the acid, and we performed this titration, and we used up, let's go with 26.12 mils of NaOH. What is the concentration of the NaOH? Let's figure that out. Well, the first thing we need to do is figure out how many moles of the acid we have. So HKC8H4O4, and we do that by using the mass 0.523 divided by the molar mass. The molar mass of this acid is 204.2 grams per mole. And so the number of moles of this acid that we have is 0.00256 moles. That's all good, but we need to figure out how many moles of NaOH we have. Well, before we do that, let's look at the equation for the reaction of these two, this acid and this base. So we have NaOH plus the acid HKC8H4O4. It's a big thing. The first hydrogens over here are acidic hydrogen, which means those are the H plus that this acid can donate. So the Na will swap with the H plus to give us NaKC8H4O4 aqueous, and that's the salt. And in all acid-base reaction, we have the OH minus and the H plus forming H2O liquid. So what this tells us is that every 1 mole of acid reacts with 1 mole of NaOH. So that means that the number of moles of NaOH that we have is the same as the number of moles of acid, which is 0.00256 moles of NaOH. But we want to find a concentration, so let's do that. The concentration of our NaOH is the number of moles divided by the volume, but the volume should be in liters. The volume that we used was 26.12 milliliters, so 26.12 milliliters, but we need to convert that to liters. And so the concentration is 0.0980 moles over liter, or that's the same as writing big M, molarity. So that's the kind of calculations and experiment that we'll do for the first part. We'll figure out how much acid we used in mass, convert that to moles, convert that to moles of NaOH, and then use that and the volume to figure out the concentration of the NaOH. In the second part, we're going to find the concentration of a sports drink, which is an acidic sports drink containing citric acid. So we're going to do a similar setup. We're going to have our burette with our NaOH. But now, because we found the concentration in the first part, the concentration is known. And then in our little Erlenmeyer flask below, we'll put our sports drink, about 40 milliliters of sports drink. We'll measure that exactly. And for those of you wondering, our sports drink is citric acid, which has H3C6H5O7. And then we're going to add indicator. Because it's an acid-base titration, indicator is there to let us know when it ends. So to give you an example calculation of how we figure out what the concentration of the sports drink is, let's say you perform this titration and the color changes after you've used, let's say, 36.15 milliliters of NaOH. Now this time around, we know the concentration of NaOH and how much volume we used, so we can find the number of moles of NaOH that we used, which will be the volume, 36.15 milliliters, multiplied by the concentration, which in this case we had found from the first part, 0.0980 molars. So that's 0.0980 molars, which is moles over liters. Units don't quite cancel out, so let's convert milliliters to liters. So now that it does cancel out, in this calculation we find that we have about 0.00354 moles of NaOH. So how much moles of the acid did we have? So number of moles of citric acid, which is H3C6H5O7, that's a long compound. Well, the ratio is no longer 1 to 1. What is the ratio? Let's look at the equation. We have NaOH, aqueous, plus our acid compound, right? H3C6H5O7. And these 3 hydrogens are acidic hydrogens. So we need to replace these 3 hydrogens with sodium. So we have Na3C6H5O7, and since we needed 3 sodiums, let's just make that 3. And then we have 3 OH minus, 3 H plus, so that will give us 3 waters. Again, this is our salt, this is our water, that's our acid-base reaction. All right, so to figure out the number of moles of acid, we started with 0.00354 moles of NaOH. And according to this equation, for every 3 moles of NaOH, we only have 1 mole of our acid. So that means that our number of moles of acid would be 0.00354 divided by 3 gives us 0.00118 moles of our acid. All right. Now that we know our moles of acid, remember we also, where is it? We also knew how much volume of acid we had. So if we know the number of moles and the volume, we can find the concentration of acid in the sports drink, which will be number of moles, 0.00118 moles, divided by volume, 40.00 milliliter. Again, we need to convert milliliters to liters because molarity is in liters. 1,000 milliliter is 1 liter. And so that will give us a concentration of about 0.0295 molars as an example. So these are the steps and calculations that you're going to do in this week's lab. We're going to look at acid-base reactions and titrations using acid and indicator in our volumetric flask. Sometimes we can add water to dissolve the acid. In our burette, we're going to have our NaOH, our base. In the first step, we're going to standardize the NaOH by using some concentration, some exact amount of acid to standardize it. And then we're going to use that to figure out what the concentration of the NaOH is. And then in part 2, we're going to find a concentration of acid in a sports drink. And we're going to use the NaOH from the first part that we already know the concentration for to find the concentration of the sports drink. If you have questions, please ask them during lab. Otherwise, I'll see you in the next video. Bye.